All right, welcome to lesson 2-15, which is unit 2, lesson 15, the remainder theorem. The learning goal is let's learn about the remainder theorem. So this is the notice and wonder thing. So if you're looking through here, we know that there are 3 division problems. We got this division problem, this division problem, this division problem here. And we look at it and we're like, what do we notice? Well, that's eye-catching. What does that mean when there's a 2 there? That's right. That 2 means that the 4 didn't divide in there evenly. There's a remainder. So the outside ones here, they divide evenly, so there's no remainder. When you have a remainder, that's an additional amount that's left over. So we notice that they wrote it that way. Well, there's nothing left over on this one, so 33 is the quotient. All right, the quotient, and the 10 is the divisor. And if you multiply those together, you get the dividend, right? But we can't do that with this b. We have to have a little extra 2 to make it work. So 4 times 82 isn't quite 330. You need to add an extra 2 there. So that's the leftover part. All right, let's go to the next page. Oh, I gotta slide this way. There we go. Now, this is a big connection that we've been working on, and that is the fact that x minus 2, which is highlighted right here in the problem, x minus 2, if you think about that as equation, x minus 2 equals 0, that's the factor. When you solve x minus 2, when you set each factor equal to 0, you get x equals 2. So that's the solution. So when it's written this way, it's the factor. When it's written this way, it's the solution to the polynomial set equal to 0. So what this means is if I put 2 into the f function, f of 2, that's going to make this whole thing 0 because one of the factors is x minus 2, and 2 minus 2 is 0. So if you put 2 into the x, you get 0, and it zeroes out the whole function. It's a 0 of the function. That's the different names we call this. X equals 2 is the root, it's the 0 of the function, it's the x-intercept. So putting 0 into the function gives me 0. So now I can figure out what u is, because that's what we're trying to figure out, what is u. So I'm going to put 0 into the function, so it's going to be 2 to the 4th minus u, and then 2 to the 3rd, plus 24, 2 to the 2nd, minus 32, times 2 plus 16. That should equal 0. That's what that means. So when it's the solution, it's the x-intercept. It's where the function is equal to 0. So now I need to simplify this. 2 to the 4th is 16. And then that 2 to the 3rd is 8, so it'll be minus 8u. 2 squared is 4 times 24 is 96 minus 64. Oops, 64. Not 34, minus 64 plus 16 is equal to 0. Now we need to simplify 16, 96, minus 64, and 16 together. Those are all like terms, they simplify together. For time purposes, that's if you add the yellows together, it's going to be 64. So now we know that negative 8u plus 64 is equal to 0. So what does u have to be? U has to be 8, because 8 times negative 8 would be negative 64. So u is negative 8. All right, now this box over here is like the multiplying box. So we're multiplying x plus 3 times this to get the stuff underneath here. All right, so we didn't do a lot with the multiplying box, but The idea here is to find the parts that match up here. I guess I'm going to go with red. So when you multiply the first box here, you get 2x cubed. So that's taken care of. When you put these together, remember the diagonals go together. That gives you the negative or the positive 5x squared. When you put these together, we get x. So it all matches. But when you multiply the 4 times the 3, you get 12. 12 doesn't match the 10, does it? Well, to make it match, we need to lose 2 spots. And the 2 spots that we lose are the remainder. So the remainder for number 1, this first one right here, the remainder for this is -2. Because -2 plus the 12 here makes the 10 over there. Now we're going to divide by x squared minus x into the polynomial. So let me do some erasing here. So I'm going to erase this out. So now I'm dividing the x squared minus x into this polynomial here. Okay, so I go back to this box. I got this matches this. Put this together. Okay, that matches here. But now this part doesn't match. I got 10 plus the x, and then I have -7x. So I got to make that match. So I got to make this part here. I'm going to make this part here with the x plus 10 match that. So what do I need to do? Well, I need 8 x's, and that'll make it x, and then I need a plus 10. So therefore the remainder is 8x plus 10. If you put 8x plus 10, if you put this with the -7x, then you get the x plus 10. So that's the remainder. All right. We're gonna skip these parts right there, and we're gonna move on to the next page. So here we go. Basically, x minus 2 is the factor, which means that x, whoops, that means that x equals 2 is the solution, right? To make the function 0, the zeros of the function. So I should do a of 2 and see if it's equal to 0. If it is, that means that this is a factor. Then I do a, not a, b, erase, erase, do b of 2, and see if it equals 0. If it doesn't equal 0, it's not a factor. So that's the deal with this. All right. So you can put 0 into the, or not 0, put 2 into the first equation here. A of 2 would be 6 times 2 squared minus 7 times 2 minus 5. So that's 24. Minus 14 is 10 minus 5 is 5. Well, it's not 0. So that means that x minus 2 is not a factor. Not a factor. So this would be a no. Now here's the weird part about this, is what if we actually did divide it? What if we did divide it? Let me clean this up again. Big eraser. What if we actually really did divide this? So we know right now that a of 0 is equal to 5. Now watch this. I am going to divide it. 6x squared minus 7x minus 5. So I need a 6x up here. 6x times x is 6x squared. 6x times 2 is minus 12x. Then I'm going to subtract these parts off. Doggone it. Subtract these parts off. Minus, plus. And then that's going to leave 5x minus 5. So that cancels out, and then it's 5, and then minus 5. Then I pick out the next thing. which would be 5, positive 5, so put plus 5 up here. And 5 times x is 5x. 5 times the 2 would be minus 10. Switch colors, subtract. What subtracting and subtract is adding. So then we get 5. So that's significant. That's the remainder. When I put 0 in, I get 5. When I divide by this to see if it's a factor, my remainder is 5. That's what the remainder theorem says. You can put a number into, oh, whoops, my number's wrong here. My number, I should be putting 2 in each time, looking for 0. Sorry, I didn't mean to confuse you. 2. So a of 2 is 5. So here's the summary of this again. I'm glad I caught that and fixed it. So you can put 2 into the function and get an answer of 5, or you can divide by x minus 2 and look at the remainder. They're both going to be 5. If they're both 0, if the remainder is 0 and then an a of 2 is 0, then that means it's a factor. But there, see, there's a remainder. It's not a factor. So that's what's going on with this. Let's do another one of these. So let's see. Let's get this out of here. All right, so here we go. I'm going to do D right here. So I'm going to synthetically divide, or not synthetically, we haven't done synthetic division, x minus 2 divided into 3x cubed minus 2x squared minus 15x plus 14. Okay, pick something out. 3x squared. 3x squared minus 6x squared. Subtract, add. 4x squared minus 15x. Need 4x. 4x times x is 4x squared minus 8x. Change the color, subtract, and add. And we get negative 7x plus 14. So now I'm picking out negative 7. Negative 7x plus 14. So when you subtract it off, you get 0. So it works. It really does work. It is a factor. Now, if I did d of 2, d of 2 would be putting 2 into this function. I should also get 0. That's what this says. So I'm going to do d of 2. So it's 3 times 2 to the third minus 2 times 2 squared minus 15 times 2 plus 14. That should also be 0. Let's see if it is. 24. So this much is 24. And then this much is 8. 24 minus 8, 16. So right now I have 16. That would be 30 minus 30 plus 14. If you put that together, you indeed get 0. So I divided, saw that there was no remainder. The remainder is 0. Or just put 2 in, and I get 0, which means the remainder is 0. So that's what the remainder theorem says, is it matches. You can divide by the factor, or you can just put the number in and see what the remainder is. Okay, so this part here said select one of them, and then we did that, so we've already done that. And then all the remainders are what you would get when you put the 2 in. So you're going to put 2 into each of those and get an answer. All right, so there's the summary of this. You can read through that. And then here's the purple page assignment. So there are 2 pages for this, and these last ones are the review ones that we've been working on. And then here's the new stuff. All right, so if you want it to have, on number 1 here, if you want it to have a, to be a 0 of the function, that means it has to be 0, right? So if you put 0 in, you get 6. No, that's not a 0 of the function. If you put in 2, you get negative 4. No, that's not a zero of the function. If you put in negative 1, you get 8, right? That's a zero of the function. So these three things here are the zeros of the function. They're the numbers that make the function 0. So they are x equals negative 2, x is equal to 3, and x is equal to 1. Now you can write that as the linear factors. On number 2, you're supposed to figure out if it's a factor. So put in 4, so make x 4, and look for 0. If 0 comes out when you put 4 in here, then it means that it's a factor. Write a polynomial function p of x with degree 3. So put in 7, right? So x is equal to 7 makes it 0. That means x minus 7 is a factor. So then you can pick any other factors you want. You just need to have 2 more, right? Because it's degree 3. That means there's 3 factors. Number 4 is kind of matching. So here, if it's negative 5, so if x is equal to negative 5, that means that it's related to the linear factor x plus 5, right? So that means A is related to this problem. So A is related to this problem because x equals negative 5 means x plus 5, which means B is related to this problem. So if you look at B related to the first thing and A related to the second thing, you can answer those 2 questions. This one here we've done 100 times. This one here, this one here you have to like divide it out twice. So you got to divide and then divide again in order to figure out how to factor it linearly. We're definitely going to go over that one in class. Here it's where you describe it. The degree is 3 and the leading coefficient's negative. Negative and odd, do 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 do. Negative and odd, do 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 do. So negative and odd means it's up on the left, down on the right. And then you put the zeros on there. Put the zeros on the old x-axis, and you make the little, squiggly thing. Oh, that's too squiggly. Make the squiggly thing through there. So if it's up on the this way, right, you're going to make it squiggle through and touch those points on the x-axis. And that's it. That's it. That's all she wrote.